Drag and drop the cube into the XPresso editor and create its duplicate. Select the red field of the first node. Navigate to the object properties. Size Y. Draw a line from the size Y output port to the blue field of the second node. Navigate to coordinates. Position Y. Right now, our cube's parameters directly link to one another. If we will change the size of our cube, the position will also be changed. But what if we want those values to still be linked, but not always equal to one another? We can pass the value through the math node, which performs math operations. Addition is the default function which adds the inputs together and outputs the result. You can add more inputs from the blue field. We can use the result node that allows us to view the result of our calculations. This node displays the input port's value. This lets you check if the value is correct. The type of value can be changed in the attribute manager. Now let's change the function to divide. Connect the output of the cube node to the first input of our math node. This specifies that we will be using the size of our cube to control first input of math node. If we will check the attributes manager of our math node, we will find only the second input. This is because the first input is being entirely driven by the cube node. Connect the output port of the math node to the input of the cube. Now, this node will send the size value of our cube to the math node. The value will be divided by 2, and the result will be sent to the position input of the cube. In computing, the modulo operation finds the remainder after the division of one number by another. For example, this expression would evaluate to 1 because 5 divided by 2 leaves a quotient of 2 and a remainder of 1, while 9 and 3 would evaluate to 0 because the division of 9 by 3 has a quotient of 3 and leaves a remainder of 0. In formal language theory and computer programming, string concatenation is the operation of joining character strings. For example, the concatenation of snow and ball is snowball. If we will concatenate the number 5 and number 2, the result will be 52. Let's change the data type of the result node to real. If we will concatenate letter P and letter I, the result will be the number pi, which is a mathematical constant, the ratio of a circle's circumference to its diameter, commonly approximated as 3.142. If we will change the data type back to string, the result will be a string value of pi. Let's create a simple clock. At first, we have to create a math node, which will calculate the seconds. Change the data type to integer, function to modulo, and set the value of the second input to 60. We can use the project time as a first input. The output of project time is affected by the frame rate. If the rate is 30 frames per second, the time value for frame 30 is 1 second exactly. And after every 60 seconds, the calculation will start from 0. Let's duplicate this math node and set its function to divide. This will define the minutes of our clock. Finally, we can concatenate these values and see the result of our calculations.